Welcome. This is Dr. Liz Musil, and in this presentation, we are going to talk about killer tips to creative problem solving. We are faced with problems every day, whether they're personal problems or business problems, and having a lot of resources and strategies on how to work with problems, defining them, breaking them down, creating steps for various types of resolutions are all part of being effective in your personal life as well as in your business. Problem solving, though, isn't just about following a strict set of steps so you can analyze everything you see. Sometimes the most difficult and challenging problems only get resolved when someone comes up with a truly think out of the box strategy that really is inventive and creative. So, your ability to use lateral thinking, which is really just thinking outside the box, can spark an idea which is epic in giving you a new viewpoint and set of solutions to solving a problem. And it'll revolutionize how you and other people see the world. So, there's excellent tools you can use to fire up your creativity and imagination in problem solving. So we're going to categorize problems into two different types, technical and complex. The right strategy and approach when you're digging into a problem depends on the kind of problem you're facing. Is it a technical problem or a complex problem? And how do you decide what the difference is? On a basic level, a problem can appear to be technical. For example, you're out of food and you need to get more food for dinner. A technical problem is usually super straightforward that has a clear-cut solution, or at least some steps that will move you towards that solution. For example, if you want to start an online business, probably one of the list of things to do would be to create a website for your business. Now, there's different approaches that you can do this, but it can be either straightforward. You can hire someone to do it for you, or you can go online and grab a couple of books, and you can go to some sites that are more intuitive, such as Wix.com or Squarespace.com, and you can start developing the site yourself. So again, there's steps you can take to approach and move forward in your problem in a straightforward manner. With a complex problem, that's kind of more challenging because you're maybe not sure what direction to take and how to solve it. It could be a new or unique problem, or there's just a lot of information that's unknown. So it's basically those situations that are maybe a little bit ambiguous or just, new and difficult. So for example, if someone told you to come up with a plan to stop climate change or to solve world hunger, probably the first thing you would want to do is do a lot of data gathering and fact gathering to make sure you understood the problem and what was going on and what was preventing these things from occurring, or what was the root source of the problem. It's not like you can sit there and say, now I'm going to do this set of 10 steps and world hunger will be, cured. So it might become more complex as you gather more data, for example, about food and growth and resources in different areas of the planet. Even if you wanted to talk about, distributing food to people in your city, maybe the homeless, again, it's very complex unless you fully understand the situation. So if you want to recognize a complex problem and try to understand it, here are a couple of prompts you may want to look at. First of all, is this a new problem or an old problem? If it's a new problem, it might need a new solution. For example, if you're working with, social media tools such as Snapchat, and you believe that your videos or your snaps don't look good because your voice doesn't sound good, you might need to take a look at, what image do you want to present on Snapchat, especially if it's going to be for business purposes. Are you going to have to create an online persona that will be appealing and support your business and your brand? So if it's an old problem, what has changed? Why will the regular solutions you've used before not work? So for another example, again, we can go back to technology And we can say, you know, the old way of doing things didn't really involve the internet. Now the internet is there, and, you know, people are approaching problems online. For example, there's online shopping now instead of going to the store. So your physical store might be losing business because people prefer to conduct their commerce and trade and purchases online. Does the problem contain many different features? Is it multifaceted? So, for example, if we wanted to look at climate change, what's causing climate change? You know, is it just our pollution, or is there also something going on in the environment that's contributing to it? The, you know, the motion of the moon or the sun, you know, that's affecting the gravitational pull. You know, if the temperature of the planet is increasing, like by 1 degree, what's that going to do to our entire system, or also coastal places that are below sea level? So, again, you'll need to gather data and information. Is the data difficult or easy to understand? Are there a variety of opinions, or is it clear cut? Is the data about the problem limited? Do you need to do independent research? And will measuring the data be difficult? So, a complex problem may seem like it's more difficult to tackle than a regular technical problem because of its size or because of its ambiguity or lack of information. But again, the more information you gather and the better understanding that you have, the better you're able to define a complex problem. To solve technical problems, you can take a systemic approach. For complex problems, however, you may need to broaden your approach and think creatively because you have to be inventive. Strategies for problem solving. Analytic strategies are used for technical problems, and as we just mentioned, complex strategies are often required for innovation. Generally, analytic strategies solve problems that are technical in nature, so that's basically a step-by-step approach where you can outline the steps of what you're going to do to solve the problem or get an algorithm or formula that will solve it to you. Complex problems, you probably will need to think outside the box and use things that are outside step-by-step procedures and formulas. When complexity strikes, it's important to start to think laterally and innovate. So again, we're going back to maybe more research, data gathering, redefining the problem, understanding the problem, investigating the various opinions and approaches to the problem, which can all lead to a solution once it is properly understood. When you analyze a problem, you can ask the question, why is this happening? What's going on? So that might be a first step in an algorithm, you know, in a step-by-step analytic problem. Heuristics, which are just experiments where you test out different ideas, are another analytic approach to problem solving, but do not provide guaranteed answers. So again, some basic analytic strategies are using step-by-step processes, algorithms, and heuristics. An example of a step-by-step process, if we're just saying, I need food for dinner, what am I going to do, would be like write my grocery list, get in the car, maybe get gas for my car, drive to the grocery store, pick out what I need, pay for it, and drive home and bring my food inside, right? That solves the problem. Algorithms, are formulas that solve problems, again, that is calculated. For example, I have my business, and my business earned $100,000 in revenues last year. I want it to grow by 25% in 2017. What would that number be? I just plug in the formula. Heuristics is experimenting different ideas. So, for example, that could be maybe done with medical research or in engineering, or again with a business type of algorithm where you're looking at, my goal is to penetrate a new marketplace and create a new product. What kind of a profit margin do I need to make $100,000 on this new product? How many units do I need to sell? So you can try various approaches and you'll figure out how to price the product. Using algorithms to solve problems. Breaking down a problem into steps that can be logically followed will lead to resolution of a problem. Computers use algorithms to solve problems that have measured outcomes. An example is the algorithm that powers Google is designed to deliver search results based on the input of the user. It's a very, very simple problem. Heuristics give a strategy of testing possible outcomes, as we mentioned, when a strategy does not exist for a specific and measurable result. Creative problem-solving strategies. For complex models, sometimes it really helps to take a look at the problem, breaking it down with some kind of visual aid, such as a model that you build, a chart, a graph, a list, a diagram. Just the act of creating a chart, list, diagram, or model makes you break down the problem in new ways, so perhaps it can be more understandable. When you create a model, you can see patterns, uncover missing steps, get a different approach or look as you compile the parts, and you can see the problem in a new way. One strategy for testing a problem is to simplify it. If you break the problem into smaller issues, it may be easier to solve. As you're connected, well, let's go back to the Google approach. How would you build a chart for a search algorithm in a search engine? A basic search would contain the following steps, and you could present it in a flow chart. 1, have an input enter keyword into a text box. 2, take the value in the text box and send it to the database. If the data in the database matches your input keyword, then yes, we're going to show the output, or no, we're going to keep searching. And then 3, finally, show the item in a list. As you connect areas of a model, you may begin to recognize patterns and words that keep popping up and behaviors that occur over and over. Using a model helps you understand your problem better, and it also helps you communicate it better. Visual communication is really terrific. Often when you present something in a graph or chart, especially if you're presenting it to maybe your clients or other people, they can grasp it visually, things that can't be put into words. And if they see the problem in a new way, they can give you communication that may help you further you in your ability to solve the problem. So it's a very, very effective tool. Lateral thinking. Lateral thinking requires looking at a problem from different angles, and we're talking about the complex problems now. There was an individual, Lewis R. Mobley, who studied ways to get creative in your problem solving and suggested some strategies. 1, ask unusual questions about an issue and explore at different angles. So sometimes it's good to even, look at an issue, but look at some of the outerlying conditions or situations that impact the issue and explore those. Return to a beginner way of thinking. Sometimes when you're an expert, your way of looking at a situation skips over a lot of steps. So going back to the beginning and trying as best you can to trace through beginner ways may give you some value and ideas. Use games, drawings, and brainstorming to uncover insights. Remember, when you're really stuck at the drawing board, you want to inspire creativity. Hang out with other creatives. If you hang out with creative people, that might give you some kind of mind-opening expansion. You'll see things in a new way. Explore your existing biases and do your best to work your way around them. That way you can remove some blocks that keep you from seeing a problem in an unbiased way. Be okay with failure and being gone. Some difficult problems, take a long, long time to resolve. So, you just want to keep on working towards determining a solid approach. So, in conclusion, problem-solving strategies for complicated, complex problems demand that you put together analytical and creative strategies. So you'll be using both sides, your right side and your left side of your brain, your logical, analytical side, as well as your creative. You want to study different techniques that have worked for others and apply them to technical problems. And as problems become intricate, though, you need to look beyond the obvious and throw away ideas that are fixed about how something works. To choose the right strategy for problem solving, understanding the nature of the problem is important. Usually, problems that are worthy of some thought are both technical and complex, and asking a series of questions or outlining and diagramming what is going on help you see the areas of complexity that you may want to further research. Turning to analytical strategies like creating formulas to solve technical problems or addressing part of a technical problem is very, very useful. Creating visual diagrams and aids and charts will help you see problems in new ways. Creative lateral thinking can help you see a big picture and find a creative angle. Just as answering lots of questions, being willing to be wrong, and investigating new strategies for modeling and games, such as diagrams and charts and puzzles. Issues can be put into perspective by simplifying them and getting the point across to an appropriate situation. So best of luck and happy problem solving. This is Dr. Liz Musil, and thank you very much.